For a long time, talking to AI meant typing words into a box. Multimodal AI changes that. Now the same system can look at a picture, listen to a voice, read a document, and answer in a way that connects them. Multimodal AI means artificial intelligence that can work with more than one kind of information. Text is one mode, images are another. Audio, video, code, charts, and sensor data can also be modes. The important idea is not the number of modes, it is the ability to connect them. This feels natural because humans are already multimodal. If you watch someone point at a broken bicycle and say, "This part is loose," you use words, vision, gesture, context, and memory together. You do not process each signal as a separate little world. A text-only AI can be very useful, but it is trapped inside language. If you describe a messy kitchen, it only knows your description. If it can see the photo, it can notice the spilled flour, the open oven, the handwritten recipe, and the missing ingredient on the counter. Think of multimodal AI like a house with many doors. One person enters through text, another enters through a camera, another speaks into a microphone. Inside, the system tries to build one shared understanding of what is going on, regardless of the door used. A common misunderstanding is that multimodal AI simply means an app accepts many file types. That is only the interface. The deeper question is whether the model can reason across those inputs. Can it compare a chart with a paragraph? Can it answer a spoken question about an image? Imagine uploading a photo of a plant and asking, "Why are the leaves turning yellow?" A multimodal model can inspect the image, read your question, and explain possible causes in plain language. It may mention watering, sunlight, pests, or soil, while still reminding you that a photo is not a full diagnosis. Before newer multimodal systems, many products used a pipeline. One model turned speech into text, another model read the text, another model generated an answer, another model turned that answer back into speech. This worked, but information could get lost at every handoff. A more integrated approach tries to handle different modes inside one broader system. The model may still use specialized parts, but it learns relationships between media more directly. Instead of only reading a transcript, it can potentially use tone, timing, visual context, and words together. A mode is just a format for information. Text is a sequence of symbols. Audio is pressure changing over time. An image is a grid of pixels. Video is images across time, often with sound. Multimodal AI has to turn these very different formats into something a neural network can compare. Large AI models usually do not handle raw human media directly. They convert inputs into smaller pieces. Text becomes tokens. Images can become patches or visual features. Audio can become short slices or acoustic features. These pieces are transformed into numbers that the model can process. If this kind of clear AI explanation helps you make sense of fast-changing technology, consider subscribing. We keep the focus on durable ideas, not hype. Now let us go one level deeper and see how the model connects a dog, a bark, and the word dog. One key idea is a shared meaning space. In that space, related things are placed close together. A photo of a dog, the word dog, and the sound of barking should land near each other. A photo of a rocket should land somewhere else. The numbers that represent meaning are often called embeddings. You can imagine an embedding as a coordinate on a giant map of concepts. The model does not store meaning like a dictionary. It learns patterns from many examples until similar ideas point in similar mathematical directions. A simple training trick is to show the model matched pairs. This image goes with this caption. This audio clip goes with this transcript. This video goes with this description. Over time, the system learns which signals belong together and which signals do not. One important method is contrastive learning. The model is rewarded for pulling matching items closer and pushing mismatched items apart. A caption about a red bicycle should match the red bicycle image, not a bowl of soup. This teaches cross-modal recognition without needing a separate label for every possible object. Another method is prediction. A model might see part of an image and predict missing details, or hear the first part of a sentence and predict the next sound or word. In video, it may learn from the relationship between motion, objects, speech, and time. Video is not just a pile of images. It includes time. A person raising a glass, dropping it, and reacting to the crash is a sequence of cause and effect. A multimodal model must track what changes, what stays the same, and how sound lines up with motion. When several modes arrive together, the system needs fusion. Fusion means combining evidence. If the text says small dog, the image shows a large dog, and the audio has deep barking, the model must decide which signals matter most for the question being asked. The real power appears when the model reasons across media. You can show a receipt and ask whether the total looks correct. You can show a whiteboard and ask for a summary. You can upload a short clip and ask what safety issue is visible. Multimodal AI is not only about input. Some systems can generate text, images, speech, music, or video. A user might ask for a product mockup, then request a spoken explanation, then ask for a short video concept. The output mode depends on the tool and the model behind it. Text-to-image generation is one of the easiest examples to understand. You describe a scene in words, and the model creates pixels that match the description. It has learned associations between visual patterns and language, such as golden sunset, glass building, or cartoon robot. The reverse direction is also important. Image to text can describe a picture, read visible words, identify objects, or answer questions about a scene. This is useful for accessibility, search, education, design feedback, and everyday problem solving. Audio adds another layer. Speech carries words, but it also carries pace, pauses, emotion, background noise, and speaker changes. A careful multimodal system may use some of these clues while also avoiding overconfidence. A tired voice does not prove what someone feels or intends. Documents are a special case because they mix text and visual structure. A form, invoice, research paper, or slide deck is not just words in a row. Tables, headings, footnotes, checkboxes, and charts all shape the meaning. Multimodal AI can use layout as part of the answer. Charts are another useful example. A text model can read the title if you type it in. A multimodal model can inspect axes, labels, bars, lines, and legends. Still, chart understanding is delicate. Small visual details can change the answer, so verification matters. Multimodal AI also matters for robots. A household robot cannot rely on text alone. It needs cameras, microphones, touch sensors, maps, and instructions. If a person says, "Put that cup on the shelf," the robot must connect language, vision, space, and action. Search is changing too. Instead of remembering exact keywords, you can search with meaning. You might ask for the photo where the dog is wearing a blue raincoat, even if the file name is just image472. Multimodal embeddings make that kind of search possible. A multimodal assistant can be more context-aware because it can see what you are referring to. Instead of typing a long explanation, you can show the broken cable, the confusing error message, or the math problem on paper. The interaction becomes closer to asking a helpful person nearby. But multimodal does not mean all-knowing. These systems can still hallucinate, misread images, miss tiny details, or invent explanations that sound confident. More input types can improve context, but they also create more ways for the model to misunderstand the world. Real-world media is messy. A blurry photo can hide important evidence. A sarcastic tone can be misread. A video may not show what happened just before the clip started. Multimodal AI can combine clues, but it cannot magically remove uncertainty from incomplete information. Multimodal inputs can be sensitive. A photo may reveal faces, addresses, medical details, documents, or private spaces. Audio may reveal voices and background conversations. The more a system can understand, the more important consent, storage choices, data security, and careful sharing become. Training data shapes what the model learns. If some languages, accents, cultures, objects, or environments are underrepresented, performance can be uneven. This is not only a technical issue, it affects who benefits from the technology and who gets misunderstood by it. A good habit is to give clear context and ask for uncertainty. Instead of saying, "What is this?" say, "What you need to know." Ask the model to explain what it sees, what it is unsure about, and what you should verify. Multimodal AI works best as an assistant, not an oracle. The big shift is simple. AI is moving from language only toward richer interaction with the world of media around us. Text, images, audio, and video are no longer separate islands. Multimodal AI is the bridge that helps models connect them into a more useful picture. If you still have a question about multimodal AI, ask it in the comments. You can also suggest the next topic you want explained, such as AI agents, image generation, voice models, or how video AI works. The best questions often become future videos.